I'm going to talk about aluminium because that's what everyone coats. So I'm going to give you some insight of what's going on. I forget the thing. I'll give you some numbers, and I'm talking primary aluminium. Year 2000, 20 million tonnes of aluminium out the ground. Year 2010, 40 million out the ground. They're squabbling over it, exact number, but last year was 65 million tonnes out the ground, plus about another 25 million tonnes of recycled aluminium. We've got a problem. There's 28 billion tonnes of bauxite in the ground. That's the raw ore that we do. If you do your numbers, in about 80 years of production at the current levels, and I'm talking 230 for orders already planned and stuff, we're going to run out of aluminium in 80 years. That means that the whole world is going to recycle more and more. And Europe has already said that by 2050, 50% of aluminium will be recycled. In the UK, we only do a token 45,000, 50,000 tonnes of primary aluminium. We actually use about 3 million tonnes of aluminium in the whole industry. We recycle very, very roughly in the UK about 800,000 tonnes to 1 million tonnes of aluminium. That number will go up to 1.6 million tonnes. And the reason we know that is because the big growth areas are packaging and automotive. With a 10-year life cycle, it'll be back in by 2030. So we are going to see more and more recycled aluminium. The bad news is about 1.5 billion tonnes of aluminium ever produced since it started being commercialised. 50% of that is still in its first use. Hence, you can't have green aluminium recycled. 75% of it is still in existence. The rest's gone into landfill, plastics, steel. That's unequaled by any other metal. Plastics, 90% have gone into landfill. About 30% of all aluminium goes into construction, and typically you're looking at 75 plus years. That's embedded carbon. That's why we got 50% in first use. Realistically, that number's going to go over 100 years, particularly in uncoated aluminium. It's stored carbon. Now, aluminium is infinitely recycled. It's never consumed, not as long as we're using it in the aluminium industry. And it really is the star of the circular economy. In terms of automotive, 90% of that is recycled. In terms of architectural, 96% of it is recycled. We absolutely love buildings because there's a few alloys, big pieces. Packaging is about 70%. That is going to grow, but you're going to see that more and more aluminium is going to get recycled. Now, at the moment, because of demand, it cascades down. It starts in high purity, electrical, aerospace, packaging, automotive, extrusions, and at the bottom of the pile are castings. The bad news is a huge consumer of castings in the UK is the automotive industry, internal combustion engines. They are phased out by 2025 in the UK. We have lost the bottom step. Now that means two things. More and more aluminium is going to get recycled within the alloy. And the sorting technology exists now that we can sort to a series, 1,000, 2,000, 3,000, but on the clasp of that, we can now sort to a grade, 1050, 6061. When you do that, all you do is remelt it and you're back in. The problem with that is tramp elements and contamination. So by 2030, we will be recycling within an alloy. And the automotive boys are exploring how to get those alloys contaminated without affecting the properties. Bad news for architecture. With a car, JLR have already worked on grades, Nissan have already got grades, where they know what the permissible tramp elements are, iron and others, because they've got very short finite lives. In terms of aluminium, I'll just throw some facts and figures at you. We are about, well, over steel, we give a typical foot weight saving of 45%. In terms of concrete, we're about an 80% weight saving over concrete. Light metal. But that lightness isn't only in the buildings, it's in the transportation, it's in the assembly, in the manufacturing. When you're handling aluminium, your production equipment goes down in scale, lower energy. Not only in weight saving. It's got a low melting point, 660 degrees C, one of the lowest melting points of all metals. Low energy, simple melting technologies. The early recycling machines were cement mixers, as you do on the site. And one of the things about aluminium is its incredibly high fluidity. The silicon alloys, the casting alloys have got the fluidity of water. Now you can cast intricate shapes. Dominated in architecture, it's starting to make huge inroads into automotive, more and more castings. The casting alloys that are being developed today now match the strength of all raw products. Bad news for us, because they're going to bring higher alloys into the recycling. The one thing that sets aluminium aside is low melting point at 550 degrees C, 500 degrees C, it goes super plastic. You're squirting tough paste out of a tube. Now you can extrude it, and when you extrude it, there is almost no limitation to the shape that you can produce. And the beauty of extrusions are, you can make woodworking joints. You don't need to weld them, you make woodworking joints, put a glue in there, you've got 100% strength, easy to disassemble at end of life. But extrusion sets aluminium aside from any other metal. Just an example of a kit build. At low temperature, aluminium actually gets stronger. Cryogenics, it's dominating cryogenics, it's dominating medical. Gets stronger, but it also gets more ductile, and no brittle ductile transition. Help. It's got incredible thermal conductivity. On a weight-for-weight basis, it's got 200% the conductivity of copper. So it's dominating air conditioning and things like that, but people are now looking at that thermal conductivity in building, underfloor heating, ceiling heating, lightweight aluminium structures. Radiators. Its electrical conductivity, 200% the weight of copper. The numbers that I always quote is, if you swap from copper to aluminium in a C-series car, large saloon, take 12 kilograms out. In the States, where aluminium is extensively used, they're taking out about 200 tons of weight out of a building from going from copper to aluminium. It's non-magnetic. Big important property when you've got lots of semiconductors, chips, computers. Magnetism passes through it like the old schoolboy experiment, iron filings on a piece of paper. It's non-sparking. Aluminium always forms an oxide, so it doesn't spark. It's not going to start you a gas fire or something like that. Any technique that you can weld or joint is applicable to aluminium. It just needs a little bit of care. But the one that I always come back to is extrusions and glue. Cheap, fast, designed, in full strength of this structure. And you can do it on site. Totally impervious to ultraviolet light. That's being used in packaging and stuff, but it's it's got incredible reflectivity, totally impervious to UV light. As we get hotter and hotter, more and more sunlight, this is becoming an issue. Incredible reflectivity. Pure aluminium, even tarnished, will reflect 90% of heat and 90% of light. That means it's being used in screens. particularly, or Michael will tell you, but the beauty of aluminium is you can use the reflectivity to put the light into a building, not the heat. And the last developments which Michael's team are using at ULC are intelligent buildings. Buildings that capture the heat during the day whilst keeping the building cool, warm it up during the night when it's cold, all made possible by aluminium. And it's soundproof. It's a light metal. It doesn't ring. It's a big sound barrier. It's not like steel. It doesn't ring. Incredibly corrosion resistant. There are buildings now, well, Eros is 1892, not 1893, in Trafalgar Square, pigeon poo and everything on top of it, no corrosion, no protection at all. Aluminium has incredible natural corrosion protection as long as it's rained or cleaned. I was given 10 minutes.